Okay, so in mathematics, we agree that we don't leave a radical in the denominator. So basically, we ensure that the denominator is a rational number. So it's called rationalizing the denominator. The square root of 3 is not a rational number, or any third for that matter. So any reduced radical is not a rational number. And you'll learn about that in the next couple of days. But for now, we're just going to look at, okay, well, how do we rationalize the denominator then? So in this case, in the example that's been crossed out here, if we want to simplify that, we can't divide it because we have a number that's not in a square root and we have a number that is in a square root. So we can't do anything division-wise there, but what we can do is rationalize the denominator, and that does simplify the expression. So to do that, we'll look at this. Yeah, I guess we'll look at this first example first. So we'll multiply by 1 essentially. So we've got 3 over the square root of 6. We want to rationalize the denominator. We're going to multiply by something divided by itself so that we're not changing the value of the fraction. So we're going to multiply by the square root of 6 over the square root of 6. So that is equal to 1. We're not changing the value of this fraction when we multiply by 1, right? All we're doing is when we multiply by the square root of 6 times the square root of 6, that is going to become a rational number. The square root of 6 times the square root of 6 is 6. If you think about it, that's the square root of 6 squared, right? When you multiply anything by itself, it becomes squared. And when a square root is squared, that cancels and we're left with just whatever is under the square root. Okay, and then in the top, in the numerator, we've got 3 square roots of 6. Now we can simplify our 3 divided by 6. We know that reduces to 1/2. So 1 square root of 6 over 2, or just the square root of 6 over 2. Okay? So similarly, in this example, remember we want to rationalize the denominator, not the numerator. There is an example, number 28, where they ask you to rationalize the numerator in the handout you're going to look at today. So in that case, you do multiply by the square root of it that is in the numerator. But here, we're rationalizing the denominator. So we want to multiply by the square root of 7 in the denominator, but we don't want to change the value of our original fraction. We don't want to change the value of this. So we're going to multiply by the square root of 7 over the square root of 7, which is 1. Okay, so remember the square root of 7 times the square root of 7 here is equal to 7, because the square root of 7 squared is equal to 7 because the square root and the square cancel. Okay, so we know in our denominator we're going to get 7. By the way, another way to think of that is we've got the square root of 7 times the square root of 7. We can multiply those numbers within the square root and we get the square root of 49. And we know that is 7. That's another way to think about it. Okay, because these numbers are both within a square root, we can multiply those and they still remain in a square root. Okay, so we've got the square root of 42 on top. And the square root of 42, we can't simplify that. If we break 42 into its prime factors, we've got 6 times 7. We've got 3 and 2. There's no pairs that we can take out of that radical, so it already is a third. So that's our final answer. So now we've got a rational number in the denominator. Okay, and just a few examples of that then. Here in fact, I'll let you do those. And then you just pause the video and you check them when you're done. Okay? Okay, and here they are, all the solutions worked out. I just want to point out in the very last example, you don't have to multiply by the full denominator. You don't have to multiply by 2 square roots of 7. You just have to multiply by the square root of 7 because that's all it'll take to rationalize your denominator. Okay.